Hello everybody, and welcome to part C of number 10, this last problem in our list of exam review problems. Okay, and this is going to be the same calculation that we did in part B, just that we're going to be using the third Taylor polynomial. So just to refresh your memory, this is asking us to approximate the value of ln of 1.1 and then to use the Taylor error formula to figure out how good our approximation is. All right, so again, P3 of x just means, okay, let's start our calculation here. P3 of x is the number of terms that we need to take from our Taylor series until we get up to the third power of x. Okay, so we need to go from here, the beginning, until there, because we hit the third power of x. So P3 of x is going to be just the part that I've underlined here, those first three terms that we've got. All right, so the idea then is we want to approximate ln of 1.1. We're going to calculate P3 of 1.1, which means we're going to take that P3 that I underlined and just plug in 1.1 for all the x's. Okay, and I'll leave it to you to verify that if you do that, just kind of crunch out all the arithmetic here, what you're going to get is 0.095333. I'll approximate that. Okay, and what we're saying is that that number is our estimate of ln of 1.1. Okay, that's the first part of our answer to C. Okay, the second part of it was to try to figure out how good is that estimate? What's the maximum possible error? How far away is it from the actual value of ln of 1.1? Okay, well, again, to use the Taylor error formula, the idea is to start by asking yourself, what's the value of n that we're talking about? In this case, it's n equals 3. Okay, and there's a value of m in that formula, which has to do with looking at the derivative of f that's one bigger than the value of n. Okay, so we're interested in the fourth derivative of our function. And we can look up at our work and see that the fourth derivative has a formula of negative 6x to the negative 4. Okay, so if we rewrite that as just negative 6 over x to the fourth, we're taking an absolute value of that, so we can actually get rid of the minus sign and just write it as 6 over x to the fourth. And then the question that we're asking is, what is the biggest possible value that that could have? That's the value of m that we're interested in. And in particular, we're interested in the maximum value of m on the interval from a to c. Remember again that the c is just the number that we're doing the approximating at, and a was given to us in the problem to be 1. So we're looking for the maximum value between 1 and 1.1. And so again, it comes down to looking at this fraction and asking yourself, where would that be the biggest if we just consider numbers between 1 and 1.1 for x? Okay, well, that fraction is going to be the biggest when the denominator is the smallest, and that denominator is going to be the smallest if we plug in 1. Okay, and so what we wind up with then is 6. That's our value of m that we're going to be using. Okay, and so the maximum error we're going to go back to the error formula. Our notation for it would be E3 at 1.1, and the formula itself looked like m absolute value of c minus a to the n plus 1, so we're going to get a 4 since n is 3, over 4 factorial, and then we're just going to fill in our pieces. Okay, so m was 6. We've got a 1.1 minus a 1. Okay, and if you do that calculation, you are going to wind up with 0.00025. Okay, and that number that we calculated there is our maximum error. Okay, so to sum it up again, okay, there were two parts to our answer to C. There was this number. That's our approximation of ln of 1.1. And the number that we found down here, that's giving us the maximum error. That's how close our approximation was. Notice that that's a pretty good approximation. Okay, 0.000025, that's a pretty small number. And you might look back at part B and ask yourself which approximation was better, the one that we got in B or the one that we got in C. I'll let you think about that.